Hello once again. Now that we know how to get Istio functioning on a Minikube cluster, let's take a closer look at some of the features, starting with traffic management. Hope you're ready. Let's get started. For this lab, I have already set up a fresh Minikube and Istio installation. I've explained these steps in my previous video. Let's take a look at the pods and services in the Istio system namespace. Okay, so we see all the pods are running and the Istio ingress gateway does not have an external IP associated with it so far. In order to be able to access applications from outside the mesh, we need an external IP to be assigned to the Istio ingress gateway service. The way to achieve that on Minikube is by running the Minikube tunnel command on a separate terminal. I'm going to use the argument -p lab because lab is the name of the profile that I have provided to my Minikube cluster. Good. The Istio ingress gateway service has an external IP assigned to it now. Okay, so the objective of this lab is to deploy an application that can retrieve customer information from a database. The application will be deployed as a Kubernetes deployment and will be associated with a service of type cluster IP. Let's take a look at the manifest of this deployment. The deployment is named customers. It contains a single replica of a pod. The Docker image for the application is available in Docker Hub at Aditya Samant Learning's Customers 0.8. The deployment has an associated service of type cluster IP and listening on port 8081. The first thing we will do is to enable automatic sidecar injection in the default namespace so that Istio injects the Envoy proxy alongside the main application container in each pod. Alright, let's go ahead and create this deployment now. Let's take a look at the pod. Okay, so we'll wait for the pod to come up. Okay, so the pod is running now. Let's take a look at the containers within the pod. You see that it has two containers within it, the application pod and the Envoy proxy. Let's take a look at the service. The customer service is of type cluster IP, meaning it is accessible only from within the cluster. Let's test that the application is accessible from within the cluster. For that, we will first deploy a sleeper pod, the manifest for which is part of the Istio package. Okay, the sleep pod is now ready. Let's exec into the sleep pod and try to access the customer's application via the customer's service. And we see an output of 3 customers with their ID, first name and last name. Great, the service is accessible from within the cluster. And now comes the interesting part. We would like to access this service from outside the Kubernetes cluster and from outside the service mesh. In a non-Istio world, the way to achieve this would be to use either a node port service or a load balancer service, or even to provision an ingress controller and configure it with an ingress resource to direct traffic to the Kubernetes service. But we're learning Istio, so we will not use any of these techniques. Instead, we will make use of Istio's ingress gateway to access the customer service from outside the mesh. So we know that Istio creates a pod named Istio Ingress Gateway, which is nothing but an Envoy proxy instance that acts as a load balancer for incoming traffic at the edge of the mesh. The pod is exposed via a load balancer service with an external IP of 127.0.0.1 in our case. In order to configure this proxy to listen on certain specific ports, we need to create a resource known as a gateway. Let's take a look at the manifest of the gateway resource. The kind is a gateway. It is named as customer's gateway and it has a selector which matches the port of the Istio ingress gateway. We have configured it to listen for requests on port 80. The gateway acts as an entry point to the mesh, but once it receives the requests, it does not know where to route the request. Routing the request to its appropriate destination is handled by another resource known as the virtual service. The virtual service resource can be configured with rules that govern how traffic flows within the mesh. Let's configure a virtual service resource to route requests to the customer's service. The kind is a virtual service. Its name is customer's VS. In the specs section, we specify the gateway that this virtual service is associated with. The hosts field lists the virtual service's host. In other words, the user addressable destination or destinations that these routing rules apply to. This is the address or addresses the client uses when sending requests to the service. In this case, we have configured the virtual service to handle all the requests coming to the customer's gateway. The HTTP section defines the rules that determines where the request will be routed. In this case, the route field has a destination defined as the Kubernetes service named customers. As the virtual service and the Kubernetes service are being defined in the same namespace, we can use the Kubernetes service short name instead of the FQDN. Effectively, the configuration is saying that all requests arriving to the gateway are to be routed to the Kubernetes service named customers in the default namespace. Now let's create the resources. Let's try to access the application through the external IP of the Istio Ingress Gateway Load Balancer service on port 80. To make the request, I will use httpy utility. And there you have it. You managed to invoke the application from outside the service mesh. Let's try the same through the browser. And sure enough, it works. Well, this was a simple scenario to get you started with Istio's traffic management. I hope you liked it and I will see you in the next course.